Today, we're gonna talk about on how to find the general term of the sequence and its limit. So now, let's find the general term of the sequence starting with n is equal to 1. Determine whether the sequence converges, and if so, find its limit. So we have here our given sequence, which is -1 to -3, 4, and -5. So what have you noticed about this sequence? So yes, you're right. This is an alternating sequence. So now, how to find the general term of an alternating sequence? So to start with, we will always use the standard formula or the standard rule in order to find our general term, which is -1 raised to the power of n. So why we should always start using this term? So because we all know that this is alternating, so we always have to use -1. So let's apply. So general term of this sequence is a sub n is equals to -1 raised to the power of n times n. So why we put n? So because we know that this sequence doesn't have any difference, right? So it starts with 1, 2, 3, 4, 5. So any number plug in into n will do, because we all know that n represent all the number of the natural numbers. So we have our general term, an is equal to -1 raised to the power of n times n. So let's see if this general term will work. So we have here our an. So an represent the number of terms. So an is equal to -1 raised to the power of n times n. So we have our number of term, which is 1. We'll start with 1. So -1 raised to the power of 1 times 1. So -1 times 1 is equal to -1. Next is our second term, so which is 2. So a sub 2 is equal to -1 raised to the power of 2 times 2. So 1 times 2 is equal to 2. So an is equal to -1 raised to the power of n times n. So we now plug in our third number of term, which is 3. So a sub 3 is equal to -1 raised to the power of 3 times 3. A sub 3 is equal to -1 times 3. A sub 3 is equals to -3. So as we look, it is correct because it matched with our general or our sequence. And to continue, if we plug in 4 into our general term, the result would be 4. So it is correct. So and for our fifth number of term, we have -1 raised to the power of n times n. So -1 raised to the power of 5 times 5. 1 times 5 is equal to -5. So our general term is correct, which is an is equal to -1 raised to the power of n times n. And now we will find the limit of our general term. So we have here our general term, which is a sub n is equal to -1 raised to the power of n times n. So limit n goes to positive infinity is equal to -1 raised to the power of n times n. So now we only have to plug in our number of terms over here, which is 1. So -1 raised to the power of 1 times 1, the result would be -1. And when we also plug in our second term, which is 2, of course, so we have here -1 raised to the power of 2 times 2. 1 times 2 is 2. So the result, if we continue solving this, the result would be negative 1, negative 1, 2, negative 3, 4, negative 5, so on and so forth. So specifically, its limit can't be determined, for we all know that this is an alternating sequence and can't be close to 0 or any numbers. Thus, the terms of this sequence oscillate between positive and negative values, with the odd number being negative and the even number being the identical. So therefore, this sequence has no limit. So this gonna be converge. So I hope you learned something from this video. Thank you so much.